Okay, our aim today is how do we prove that a quadrilateral is a parallelogram? So let's talk briefly about what it is I'm actually trying to prove. If you remember, there were a series of properties of parallelograms, and we said that if a quadrilateral is a parallelogram, then certain properties hold true. Number one, both pairs of opposite sides are parallel, right? That's the definition. Also, we discovered that both pairs of opposite sides are congruent. And if you looked at the previous proof, I actually proved that if both pairs of opposite sides of a quadrilateral are congruent, you have yourself a parallelogram. This is the one I would like to focus on now. If a quadrilateral is a parallelogram, then I know that both pairs of opposite angles are congruent. So I'm focusing on this piece of information right here. So if both pairs of opposite, if a quadrilateral is a parallelogram, both pairs of opposite angles are congruent. How do I know that if a quadrilateral with both pairs of opposite angles are congruent, it's a parallelogram? In other words, what is the converse of this theorem? What is the converse of this theorem? Well, the converse is as follows. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. How do I know that this is true? Is this true? And the answer is, it is true. That is a theorem, that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. How do I know? Well, let's take a look. Let's draw ourselves a quadrilateral. There we go. A, B, C, D. And suppose I'm given the fact that angle A is congruent to angle C, and angle D is congruent to angle B. How do I know that this is a parallelogram? What I'm trying to show is that both pairs of opposite sides are parallel. Right now I don't know that, but I want to show that. If I can show that AB and DC are parallel to each other, and DA and BC are parallel, if I can show this, and if I can show this, then ABCD is a parallelogram. Question is, how do I go about doing it? As we said before, much of what we do with proving whether or not a quadrilateral is a parallelogram is using triangle congruence. However, in this case, we're not going to do that. But what we are going to do is show that certain angles are equal to each other, and therefore certain properties must be true. In other words, I want to show that AB and DC are parallel to each other. Let's give these angles names. Let's give them variable names. I'm going to call this x. I'm going to call this x. I'm going to call angle A y. I'm going to call angle C y. Now, I know that there is a polygon angle sum theorem that says the sum of the interior angles of any polygon can be derived by using the formula n minus 2 times 180. Right? This gives me the sum of the interior angles of an n-gon. N-gon meaning n can be any, oh, that looks awful. N can be any number of sides. So in our case, our n-gon is a quadrilateral. It's a four-sided figure. It's got four angles. It's got four sides. So I know that 4 minus 2 times 180 is equal to 2 times 180, which is equal to 360. So I know that the sum of the interior angles of this quadrilateral is 360, which means, and I'm going to use the variables, x plus x, x plus x, plus what? Plus y is equal to what? Is equal to 360. Okay, I know that. So x plus x is 2x, so I have 2x plus 2y is equal to 360. Now if I want, I can factor out a 2, so I have 2 times x plus y is equal to 360. And if I want, I can divide both sides by 2, right? And I'll know that these 2's cancel out, and I'll know that x plus y is equal to 180. Well, that really helps me. Why? Because if x plus y is equal to 180, then I'll know that these two angles, namely this angle x and this angle y, are supplementary. If they are supplementary, let's think about what I've got. I've got two lines. Here's line DC. Here's line AB, and here is my transversal. And these two angles, angle X and angle Y, are same side interior angles of two lines cut by a transversal. And if it's true that X plus Y is equal to 180, that same side interior angles, same side of this transversal T, interior on the inside of these two lines, line AB and line CD. If same side interior angles are supplementary, what must be true about AB and CD? Well, they must be parallel. That's the converse of the same side interior angle theorem. I also know that these two angles, X and Y, they are supplementary. We've got that right over here. Well, if those two angles are supplementary, what does that mean? Well, I want you to focus on these two lines now, BC and AD. I have two lines, BC and AD, that are cut by a transversal. We're going to call this transversal T2. If these two angles, these same side interior angles, are also supplementary, well, that must mean that lines AD and BC must be parallel. Well, if both pairs of opposite sides of a quadrilateral are parallel, what is that quadrilateral? Well, it's nothing other than a parallelogram. So, it is absolutely true. This theorem belongs in your notes. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. If you need to, put your player on pause, take down the theorem, take down this diagram, and this diagram as well. And then we'll come up with a formal two-column proof with statements and reasons. Okay, let's get started. So, here's the question. Given A is congruent to C, B is congruent to D, prove that ABCD is a parallelogram. So, my first statement is going to be angle A is congruent to angle C, and angle B is congruent to angle D. And the reason for that is given. Now, they're also telling you that, they're giving you a hint. Let B equal X and let C equal Y. So I'm also going to give this value X, and I'm also going to give angle A's value of Y. Okay, so what can I say? I can say that X plus Y plus Y is equal to 360. The sum of the interior angles of a quadrilateral is equal to 360. Why? Well, I will call that the polygon angle sum theorem, which basically says n minus 2 times 180 gives you the sum of the interior angles of any polygon with n sides. Okay, and then what I'm going to do is I'm going to combine like terms. 2x plus 2y is equal to 360. Right? And what I did is I combined like terms. And then what I'm going to do is I'm going to factor 2 times x plus y is equal to 360. And then statement number 5 is I'm going to divide both sides by 2. So that means that x plus y is equal to 180. If you want, you can show that you're dividing both sides by 2. That is perfectly fine. Now, if that's the case, okay, the question is, what do we call all this stuff? Do we want to say math? Do you want to say combining like terms? It's all of those things rolled into one, right? So the reason you can give basically is computations using polygon angle sum theorem. That's exactly what it is. All you're doing is you're doing algebra, computations, algebra, whatever you have. Well, let's see what that means. If x plus y is equal to 180, what you can say right now is that, remember, x plus y, let's take a look at these two, x and y. If x plus y is equal to 180, that means that BC and AD must be parallel, right? Line segment BC must be parallel to line segment AD. And what else? Well, now let's take a look at this x plus y, namely this x and this y. That means that BA is parallel to CD, right? So you can also say that BA, line segment BA, is parallel to line segment CD. Reason for that? Converse of same side interior angle theorem. Well, what's our seventh and final statement? ABCD is a parallelogram. ABCD is a parallelogram. Why? Because that is the definition of a parallelogram. Both pairs of opposite sides are parallel. And there you have it. Please put your player on pause. Take this down. This needs to be in your notes. You need to have this proof. This is what you're asked to prove. This is the two-column proof. Put your player on pause. Make sure you've got it.